Hello, welcome back to our course. Today we're going to talk about section 4, how to mine data and store it. So there are 4 subsections. So first one is text mining, second is network mining, and third is Python matrix library. And lastly, we're going to talk about SQL, which is a very powerful tool for you to query big databases and then save your data into the server. So let's get started. First section is text mining. So we can actually, as usual, import all these libraries. So, and then I want you to go to this data set that I actually show you a link in here that you will get spam data, collection data for SMS. So then we're going to do some text analysis based on this data. So I have already downloaded data, so you can actually see, as usual, we'll use Pandas library to read the table. We're going to read the table because this is a text file, so that's why we are going to read the table. And then I put header as none because there's no column headings that were given to us. So therefore, we're going to actually assign it like this. So we're going to call this Pandas data frame as MS S underbar raw, right? So we can actually call it DF, but this time we're gonna actually call it MS S underbar raw, and then columns. This is how you can actually do it. So then, like, we're gonna actually take a look at first the first 2 rows. It's running, so you can actually see spam, ham, right? So we can actually, if you grab more, you can actually see ham, spam, spam, and you can see the message itself in here. So, okay, that's great. So then let's look at the value, right? So we can actually do SMS underbar row spam dot value counts to see the split between ham and spam. So you can see that spam we have like about 700, and then ham we have about 4,800. So okay, yeah, so that makes sense. Then and then we can actually quickly look at something like, let me insert it, so MS and then raw, and then remember the shape. That's pretty convenient, right? So we have the shape, and then you can actually see we have 5,600, and then 2 columns, which will have spam, ham, and then the message itself. So now let's do some text analysis, right? So under the hood, NLP or text analysis is really about converting the words into columns, right? So into our features. So that means every word, right? Every word like this, right? Click, offer, winner, they are going to be used as features, right? So in a way that we're trying to just pivot this whole thing, right? Pivot this like original DF. We have ham spam. Whenever we see like free, whenever we see like click, whenever we see winner, money, we want to use flag it as one. So we can actually create a bunch of dummy variables, like binary variables with like yes, no values in it, but we're going to create many of those features. Remember, each feature is a word, right, that we can handpick like this, right? So we can actually handpick it like this. So what we're saying is that, okay, whenever you see these words, right, cash, urgent, maybe we're gonna add money as well, then we want to kind of like we think that there's more chance of this message being a spam, right? So I mean, whenever you say cash or free something, yeah, it's likely that you're getting spammed. So okay, so we are constructing this list of keywords, and then what we're saying is we're creating a for loop, right? So for key in keys, remember, like this is how you can actually create a for loop, right? And then it's gonna go through this one by one, and then what we're saying is, okay, SMS underbar raw, right? Dot message is the second column with the actual message. Dot string, we're converting it to string. Dot contains, whenever it contains this word that we're talking about, right? Then we want to actually, flag it as like true. Else it's gonna be false. That's what we're doing, right? And then I added some like space in here. I mean, just because we typically have space before and after, so that's the reason that you can actually see space plus string, right? You're converting this key into string, even though it's already string, just to make sure that we're forcing it to be a string, right? So, and then we're gonna do this for all the keywords. So let's run this, right? And then you can actually look at let's look at the head, right? The head is going to be, okay, this is our original, we had the spam, message, the 2 columns. Now we have click, right? Click is coming from here, offer, winner, buy, free, cash, urgent money. You can say false, 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 false. That means this message doesn't contain any of these like keywords that we handpicked, right? So, but what if we look at more, right? Like, okay, we're gonna look at more than just 2, and then you can actually see, okay, some are true. I mean, even though most of it's are false, actually. Okay, let's see. Pick an example where you have some true, right? So you can actually see true, right? So that means, okay, free. This one has like free, right? Like free, right? You have the free in here, so therefore this one is being flagged as free. So you can see that this matrix is going to be a sparse matrix. So most of the values are actually false or 0, and then just only some trues or some ones, right? Okay, that's cool. Then let's look at, this is actually a pretty, another feature I was thinking. So what if, all of these, the words that you see in the message are capital, right? So that's kind of like a good indicator for like spam, because whenever you see all capital, that's kind of, it doesn't look real, right? So therefore, I would just say, okay, if you have any like upper is actually a function that's coming from this string, right? So it means like if this is all upper, then I want to flag it as true, and then I want to assign it to this new column that's called all caps, right? So this is to check if it's caps or not, right? Because that's a good indicator for like spams. And then we can actually look at the head. So like, yeah, this is how you can append a new column. So therefore you have a new column that's called all caps, right? So it's called, I mean, it's false. What if we, if we try to find something, remember how to slice our df, it's say, it's true, right? And then we want to put this outside to see if we get any truths, right? Obviously, yeah, there's like some truths, yeah, like a hate date, Sunday, yeah. So it looks like these are like mostly, well, yeah, can be spam. So you can see there are a bunch of truths as well. So, okay, so let's then move on. So let's look at the correlation matrix, right? So remember, SMS, SMS raw and then the core is going to give you a correlation matrix only on the numerical values. Now we can actually plot it using Seaborns to get the heat maps, right? You can actually see the diagonal is going to be 1 because it's itself, but we do see some like, free, cash, there's like offer, winner, all these like have some sort of like higher correlations, right, towards like spam, right, being spam. So all right, so let's then look at, split our data, right, into like feature and then and target. So our data or the feature matrix, right, is going to be, right, this is actually kind of like a funny thing that we're doing here, but remember, this keywords is a list, right? You have a bunch of lists, and then this is our another column that we have created. So this is going to pass a list, right, with the keywords and then all caps, and then we want to slice our original SMS raw to only grab those columns, meaning we're only going to be grabbing click, offer, winner, all the way to like all caps, right? So these columns are going to be our features, right? But then remember, in NLP, right, you don't want to pass the text as is. We have to convert the text into these like almost representation by the words, right? And then you're gonna have the values, like the numerical values or Boolean values inside in here. So this is a Boolean value, it's like yes, no, but you can actually assign some sort of weights, right, in here, right? But at the end of the day, you kind of have to have the numerical values inside, right, the feature matrix, not the text itself, right? So okay, now so we can actually, let's run this and let's see how it looks like, right? So data, remember, is our feature matrix, right? Dot head is a matrix, so we can actually do dot head, right? So yeah, like all this, right? So now what if we want to look at target, right? Target is going to be just the entire column, right? So let's just say target. Right, so okay, so you can have spam, you have all these things, right? So this is what we're trying to predict, right? Okay, so great. So now we can actually fit a model. Remember last time we talked about different models from sklearn. So now this time we're going to use naive Bayes, right? So naive Bayes is, the name suggests, as the name suggests, it's naive, and then Bayes is using Bayesian's rules. So pretty much you have some sort of like prior information, and then with the added information, you can update your prior knowledge and then come up with posterior, right? So that's kind of like what that is. But let's just use this model, right? It's as a classifier. So we're gonna actually do this Bernoulli and Basel because we have only 2 classes, right? So spam and hem. So now we can actually start this model and then give a variable that's called BNB, right? And then we're gonna fit it with our feature, and this is our target. And now we're gonna create this Y predict, which is BNB.predict, and then pass the data inside. And now this is how our results will look like, right? So what we're saying is, okay, out of this like original, 5,600 almost data points or messages, the number of mislabeled points are like actually 604, right? So we are doing okay job, right? The rest of the messages are classified correctly. So like we can actually take a look quickly, right? Like remember the confusion matrix that we might have to import it. So scalar dot matrix, and then no, let's do it from. So and then we can look at the type 1, type 2 error, right? So confusion. Oh, actually it's not matrix. Is it cross validation or matrix? That was matrix. Okay, confusion. Let me just. Oh, should I think I misspelled this one. Yeah. Okay. Let's see. Although I'm like trying to find it. Confusion. Okay, this one. I just wanted to like do the confusion matrix. So a scalar confusion matrix. Okay, so this way we can actually we will get to the type 1, type 2. So matrix, yeah, that's great. A scalar. Okay, let's just copy over this whole thing, right? As you can see that a lot of time, I will have to Google it. So and then we're gonna import this thing, and then all right, great. So now let's do something like the usual trick that we always do, confusion matrix, and then our target is the real the true one, right? Like the one that we already have, like spam or ham, and then Y predict is going to be the labels that we have predicted. So you can actually see, okay, yeah, type 2 error is kind of bad, right? So most of the things that we're making mistakes are coming from spam, which is kind of like not, it doesn't really serve our purpose, right? So in a way that, yep, the overall accuracy is okay, but if you look at type 1, type 2, it's not so great. So what I will do next is really just to first enhance this list of keywords, right? I will do like, maybe I'll pick more, right? Manually pick more and see how it works. Like, if I do like some other, like I'll look at some other keywords. And then the other one is I can look at the top words that are, included in spam, right? What are the top words? I can do some of the word counts and then use those as a keywords. And lastly, this we're gonna talk about in the last section, right? Section 5 is vectorizing the messages. So that means not only these words, but I am going to vectorize all of the words, right? Using a sklearn's count vectorizer, like bag of words, or TF-IDF. So that way, I believe that we can increase we can enhance or improve our type 2 error, and also like we can create some sort of like features like this, right? All caps or the number of words in that message, in each message, right? We can actually use that as a feature, or number of punctuations, or number of sentences, right? So those might be a good feature, so we'll have to kind of play with it. But so far, I mean, this is to just really give you an overview of, text data analysis. So like I said, in, section 5, we're gonna actually do a deep dive into NLP. So thank you.